Welcome to this introduction of CTC's MEP Productivity Pack for Revit. This video will introduce and overview the electrical content, features, and workflows in the Productivity Pack. When we discuss electrical content, we usually refer to the pack as the Electrical Productivity Pack, or EPP. The Electrical Productivity Pack is a content pack for electrical design within Revit. The pack includes a sample project and a starter project, as well as family content and supporting files. The sample project is a completed building design intended to demonstrate the EPP's features on an actual project. It can also be used as a sandbox for testing and exploring. The starter project is a starter or template file for starting new projects within Revit. It contains all of the settings, parameters, schedules, views, sheets, preloaded links, and work sets required to get a new project up and running quickly in Revit. The starter project is where we will begin our overview. Setting up consistent standards within Revit requires strong knowledge of Revit and takes lots of time. With the EPP, you can skip this step altogether. The starter project already has consistent settings in place, like object styles, project parameters, electrical settings, phasing settings, view templates, and view filters. We'll touch on some of these settings in more detail later in the video. Let's move over here to the project browser and take a look at how the starter project is structured. Here, we have pre-configured views in several categories. Let's first look at project setup. We can see here that there are workflows already set up for working with either linked Revit or linked CAD files. 10 floor plans are already set up. The user manual describes a workflow that you can use to link in models for use with these existing views without losing functionality like copy monitoring grids and levels. This way, we can already have the visibility graphics settings in place for these links in our view templates. If you don't need all of these levels, or for that matter, if you don't need certain subdisciplines like nurse call or fire alarm, the content provided includes a dynamo routine, which will automatically purge things that you don't need. If the project has only levels 1 and 2, for example, the routine will automatically delete other levels, views, and sheets that you don't need. For those of you working with clients or consultants who are using AutoCAD, these AutoCAD link views are part of a workflow to set up these backgrounds in a way that the graphic settings can be quickly applied to all views without having to change graphic settings per view or per view template. As we'll see later, all EPP content is fully functional when working with 2D AutoCAD backgrounds as well as with linked Revit models. After the project is set up, we can immediately jump into modeling. The views are already here to work in. Let's expand construction documents, and we see that we have subdisciplines set up. Let's look at power. We have floor plans and drafting views. Drafting views is where we store our power-related details. Here we see that not only do we have levels set up, but we have dependent views that can be used on large footprint buildings, complete with match lines and sheets. These can also be purged with the Dynamo setup routine if not needed. Let's take a look at some schedules. Here's a list of all details within the project and the sheet that each detail is placed on. We have various note blocks, sheet lists, and some schedules used for project-wide settings. These settings are used to select electrical code compliance. The EPP's automatic calculations support the Canadian Electrical Code as well as the US National Electrical Code. And these schedules for minimum wire and conduit size and overcurrent protection are used in automatic calculations. I'll show you later in the video that the EPP can automatically calculate some circuit information. And here's a quick peek at the rest of the schedules available. We'll come back to a couple of these in a minute. Panel schedules normally live just below schedules in the project browser. There are no panel schedules in the starter project because there are no panels modeled, but let's take this opportunity to look at the panel schedules pre-configured in the pack. We have only one branch panel schedule in the template. I say only one because you're probably used to seeing several templates here for various purposes. We have consolidated all of that functionality into a single schedule. This one schedule can handle main circuit breaker or MLO panels, feed through lugs or not, any number of breaker positions, and more. The same schedule is pre-configured for circuits down, circuits across, or single column panels. We have 3 different methods for modeling switchboards, with schedule templates to support all of these methods. You can use a single switchboard schedule, you can schedule each distribution section separately in a single schedule, or you can schedule each distribution section separately with per section loads. You can choose which method you use depending on your firm's preferences or the needs of the project. All of these schedules are described in detail in the user manual. Next, I'd like to show you that we have sheets already set up and configured. Views and keynotes are placed on the sheets already, so when you bring in your own architectural links, you just need to reposition the view on the sheet, choose the correct title block, and then double-check the sheet names and numbers in the sheet schedule. You can skip sheet creation. Now I'd like to take a look at family content in the EPP. The EPP contains over 130 families. These families are all new in the Revit 2020 release of the pack, except for lighting fixtures, which were new last year. Users of former versions of the pack may realize that there are a lot fewer families. We have reduced the family count by more than half, but we haven't sacrificed functionality. In fact, we've increased functionality. The new electrical content can do more than ever before while having a lighter load on your system, use less storage space, and have simpler library management. To explore, let's go back up here to our test element views. These views have nearly every type placed for all electrical families for inspection and testing. Let's take a look at electrical fixtures first. Here we'll see the general arrangement of all of the electrical test element views. Every type of every family is placed, both hosted and unhosted where applicable, and every type is tagged with family name and type. Let's take a look at the first feature common to most electrical families. The EPP's content can be placed either hosted or unhosted. If we look here at these duplex receptacles, the ones on the right are identified as hosted, and the ones on the left as unhosted. If we try to move the one on the right, we can see that I can't move it off of the wall because it's hosted to the wall, and if the wall were to move, the receptacle would move with it. This is how most Revit content works. The one on the left, however, can be moved anywhere and rotated any way that we want. But the most important thing to see here is that both of these devices are the same family and the same type. This way, if your firm sometimes works with Revit links and sometimes works with AutoCAD backgrounds, you do not have to maintain two sets of content. The EPP families can be used either way. To demonstrate another feature common to many electrical families, let's look at this family generic electrical fixture. Throughout all of the EPP's content, wherever practical, we allow users to build your own symbol. If we take a look at these devices, notice that they are all the same family. We have built in graphic options so that you can make the symbols look pretty much like anything you want. Down here we have a demonstration type set up for testing. If you run into an oddball situation where you need an oddball symbol, you can build it with this family rather than creating an entirely new family. Another place to see the power of our build your own symbol approach is with fire alarm devices. We have only two notification appliance families, one for the wall and one for the ceiling, and only two detector families, one for the wall and one for the ceiling. All of these ceiling detectors are the same family with different graphic options selected. Likewise, all of these notification appliances are the same family. By default, fire alarm device symbols are based on NFPA 170. But using the symbol options, you can configure the symbols to match whatever standard you follow. Let's take a look next at electrical equipment, and we'll look at the panel boards. All of these panel boards modeled here are the same family. You can configure our panel board family to represent large distribution panels like Square D I-line, or load centers, surface or flush mount, multi-section panels, main lug or main breaker, feed-through lugs or not, hosted or unhosted. Everything you need is here. Let's take a look at clearances. Here we have built-in working clearance. The clearance's depth calculates automatically based on voltage to ground per the NEC, but its depth can be manually overridden, so you are ultimately in control. It can slide back and forth along the face of the panel. In 3D, we have dedicated space whose height is easily adjustable. And we can change family settings to automatically convert the clearances to comply with the Canadian electrical code instead of the NEC. All clearances in the EPP work this way. The last feature I'd like to show you in this intro are automatic load calculations. To see this, let's take a look at our equipment connection schedule. This is a working schedule that shows us a ton of information about each piece of equipment that's in the project. I don't have time to demo all of this information here, so I've set up a demonstration schedule with only a few columns. Here we have an equipment connection schedule showing horsepower, electrical voltage and loads, overcurrent and conductor sizes, and conduit sizes. What I want to show you is how quickly we can get to preliminary design parameters. Suppose we have a 60 horsepower motor at 480 volt three-phase. I simply have to enter 60 horsepower in here, and the project will calculate all of the circuit information for me. The project will perform linear interpolation if we enter an in-between motor power, or if we're not working with a motor, I can enter apparent power directly and everything else calculates. In this demonstration schedule, I'm only showing the input column for apparent power, but all of the data you see here, every single column, may be manually overridden if needed. There are settings for how automatic calculations are performed, like overcurrent protection type, copper or aluminum conductors, conductor temperature rating and conduit type. These values will calculate according to the US National Electrical Code or the Canadian Electrical Code depending on project settings. The user manual details how the calculations are performed for engineering review, but all values can be overridden, so ultimate control is always in the hands of the designer. Unfortunately, we simply don't have time in this introduction video to cover a ton of features available in the EPP. We haven't talked about the sample project, busway, plug mold, working views, or circuiting, nor do we have time to look into lighting. We have a separate lighting overview video that we encourage you to check out. The link is in the description. All of these things are built with advanced features and workflows to make modeling electrical systems in Revit faster and easier than ever before. We hope you'll take the time to download and review our free information packet about the MEP Productivity Pack, which includes our entire user manual to fully explore the product. You can find that link in the description below, as well as information about how to schedule a personalized product demonstration for your firm. Thanks for watching.